This video, I want to discuss, first of all, finding the measures of center that we've learned about, which are the median, the mean, and the mode, identifying any potential outliers, and then I also want to look at the main idea, which is how the mean and the median change if we remove the outlier once we identify it. So in order to do this, we're going to look at this data set. We've got some scores that are earned on a midterm exam in somebody's class. So these are the scores that were earned. And let's go ahead and just find the different measures of center. First, let's find the median. So that's our middle value, and I can find those by just figuring out which term is in the middle or which value is in the middle here. In this case, I have two numbers in the middle, so I'm going to have to do 68 plus 70 and divide that by 2, and I'll end up getting 69. So that's my median. So my median is about right here if I were graphing it. Okay, and then what about the mean? The mean, I actually have to add all of these data points. I'm going to add all of them, and I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to add, and then I'm going to divide the sum divided by 12. So let's go ahead and add them up. You just grab a calculator and start adding up your data. My sum is 874, and if I divide that by 12, I end up getting a mean of 72.8, which is about right here if I were looking at it on this number line. That's your mean. And then we can find our mode. Our mode is just the value that appears most often. So the 67 is there 3 different times. So it looks like our mode is 67. And then we can also look at our range. Our range is just going to be the difference of the highest minus the lowest. So that'd be 100 minus 63, which is 37. So that's our range. Okay, so now that you have your measures of center, think about, does it look like there's an outlier in this data? If you're looking, you have most of your data here between 60 and 90, and then you have this random person who got 100% out here. So this looks like it's your outlier. And if you look at your data, it looks like it's skewed to the right. With that outlier included. So let's see what happens to our mean and our median if our outlier is removed. So what we're going to do is we're going to recalculate the mean and the median without the 100. So if I were calculating my mean without the 100, that's going to be 774 divided by 11, because I removed this 100, so there's only 11 terms now. So my new mean without my outlier include is 70.3. And then if I were to calculate my median without the outlier included, so the median, that's just going to be without this outlier. So my median is going to be 1, 2, it's just the middle value, 4, 5, it's 68. So what happened? The median decreased and the mean also decreased, because the mean used to be 72.8 and the median was 69. So what happened is both of them decreased. And what that means is that with our outlier included, our mean and our median of our data set looked higher than they really are. Okay, so then let's look at another data set. Here we've got the number of minutes it takes a student to walk to school from home. And I plotted the number of minutes on a number line and made a dot plot. And if you look at your data, you see you have most of your students taking from 10 to 15 minutes. And then you have one random student that probably lives next door to the campus that's only 1 minute away. So if I were to find the mean, the median, and the mode of my data set, my mode is going to be the one that's the most easy to find, which is going to be 15. That's the one that occurs most often, which is 15. And then my median, that's my middle value. So I can just find my middle value. I got 2 13s. So basically, if you added them up and divided by 2, you're going to get 13. So that's my middle value, is 13. My mean, I'm going to add them all. And I'm going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 students. So let's add up the number of minutes that all the students take. So 1 plus 10 plus 10 plus 10. And then you've got 11 plus 11. 12 plus 13 plus 13 plus 13. Plus 14, plus 15, plus 15, plus 15, plus 15, and then you have plus 16. And you have to divide that by 16, which is the number of students. So our mean is 12.1. So the mean is 12.1, which is approximately right here. Our median was the 13. And then what we want to do is look at any potential outliers. In this case, the outlier that I would think would probably be 1. Excuse me about that. It's a lot lower than all the others. So the 1 is a lot lower than all the others. So let's see how the mean and the median change if we remove that 1. So let's just get rid of it. And what we're going to do is we're going to recalculate. Okay, so let's recalculate our mean. All I'm going to do is I'm going to calculate my mean without that 1 included. And I'll divide by 15 now because now I only have 15 data items. So it becomes 12.8. And then for my median, if I don't include this 1, then I'm looking for the middle number, which would just be 13. So my median doesn't end up changing. But my mean is a little bit higher. So it looks like that 1 was making it seem like everybody lived a little closer to school than they really do. This was your outlier. So the big idea is that the outlier will make the mean lower if it's skewed left, higher if skewed right. So for example, if you've got some random data value and then everything else is located over here, your mean is going to get pulled to the left. So if this was the middle, your mean is going to get pulled that way. And if you had data that was mostly on the left and then maybe some really super high number, and this is your mean is going to get pulled to the right. So your mean looks higher with the outlier included. So sometimes people will exclude the outlier in order to make the mean look more representative of all the other data values.